November 11th. Once again, the cosmic canvas peels back, revealing terrifying new secrets. An object designated 3I Atlas plunges relentlessly toward our sun, a celestial dive whose impact is not one of destruction, but of profound revelation. For days, the echoes of its violent interactions with our star have resonated across the scientific community, not as a cataclysm, but as a series of unprecedented insights. Each encounter brings not annihilation, but enlightenment. With every approach, Atlas unveils another secret challenging the very bedrock of our understanding. Laws once thought unshakable begin to tremble under the weight of its defiance, and in the space between established fact and audacious possibility, something extraordinary begins to take shape. A question: has nature just revealed a fundamental new law of the universe? Or are we in our quiet watch, witnessing the lingering trace of something that was deliberately made? From the cautious hypotheses of astrophysicist Avi Loeb to NASA's uncharacteristic prolonged silence, from the delayed release of vital images by the Mars Reconnaissance Orbiter to the urgent calls for transparency from the US Congress, the story of 3I Atlas has long surpassed the boundaries of mere physics. It has evolved into a profound mirror reflecting the human mind itself, how we confront profound mystery, how desperately we cling to the comfort of existing knowledge, and how instinctively we tremble before the truly unknown. And so right now we turn to the latest findings and official reports, sifting through the data to explore what astronomers have discovered in these recent bewildering days as 3I Atlas, the enigmatic interstellar wanderer, continues its dramatic, perplexing dance with the sun. At first, 3I Atlas looked unremarkable, a dim interstellar wanderer, a mere whisper of dust and ice following an expected path around the sun. Then almost overnight, everything changed. Just 3 days ago, as it passed perihelion, its closest point to the sun, telescopes around the world recorded a transformation no one expected, no model could predict. Its brightness suddenly increased fivefold, a brilliant, unexpected flare in the cosmic dark. Yet its structure refused to behave according to any known cometary physics. Instead of a single predictable tail streaming away from the sun, the object released multiple jets, a chaotic ballet of light and motion, each plume carving a different trajectory through the vacuum. And the most recent research confirmed the most unsettling observation. One of those jets, the strangest of all, was headed straight for the sun. No comet should do that. In the realm of classical physics, the relentless pressure of solar radiation acts like an invisible broom pushing dust and gas outward away from the star, forming the luminous tails that always point away from the sun. To witness a jet resisting that force is like watching a river flow uphill, a fundamental defiance of an immutable law. Yet here it was, a plume of gas, a ghostly thread defying sunlight itself. Initially, the discovery was dismissed an understandable reflex in the face of anomaly, perhaps an error in angle, a misreading of data, an optical illusion of scattering. But as days passed and observatories from the arid peaks of Chile to the volcanic slopes of Hawaii confirmed the same bewildering behavior, the anomaly persisted, solidified. The jets were not chaotic bursts, they were stable, almost structured. They formed a pattern that repeated, measured, deliberate, almost mechanical in its precision. Spectroscopic readings deepened the puzzle, plunging the scientific community into a new layer of confusion. The outflow velocity of the gas was only about 150 meters per second, a mere fraction of the force needed to resist the sun's formidable wind pressure. Such weak jets should have bent, dispersed, dissolved into the solar gale. Instead, they held their shape, standing like invisible columns of energy, anchored somehow to the object's elusive nucleus. Every existing physical model failed to account for this. If the intense heat from the sun caused this activity, the effect should have been random bursts of sublimation, sudden violent eruptions, short-lived flares that dissipated quickly. But Atlas showed continuity, a sustained, almost rhythmic emission. The jets pulsed in cycles precisely aligned with the object's slow 9-hour rotation, as if responding to an internal command, a hidden clockwork. To imagine it is to picture something breathing in the profound silence of deep space, a dark, ancient stone exhaling threads of vapour, each in perfect rhythm with its stately spin, a cosmic heartbeat in the void. It was mesmerising and deeply, viscerally confusing. Theories multiplied, each attempting to grapple with the unprecedented. Some scientists proposed that the jets originated from venting stratification layers of gas trapped beneath a crust and released through different random cracks as the surface fractured. But this hypothesis, while plausible for some aspects, couldn't explain the stability, the persistence, or the precision of the jets. Others blamed rotational bias, suggesting the comet spun fast enough to expose multiple hot zones sequentially. Yet its measured rotation was too gentle, too slow for such an effect. The physics simply didn't add up, leaving the field open for cautious, yet unavoidable speculation. Perhaps the venting wasn't random at all. Maybe it was directional, guided through narrow internal channels functioning like miniature nozzles, focusing the gas into precise columnated jets. If so, 3I Atlas was doing something no natural object had ever been observed to do, adjusting its own motion, exhibiting a form of self-regulation. Could an ancient fragment of rock and ice truly possess a mechanism that mimicked propulsion, a capacity for controlled emission? It sounded impossible, almost anathema to the principles of celestial mechanics, yet it fit the perplexing data better than anything else. Computer simulations at the European Southern Observatory compared two starkly different models, one of random outgassing and another of guided channeled flow. The first, the random model, collapsed into noise within hours, unable to reproduce the observed stability. The second, the channeled emission model, remarkably reproduced the exact jet geometry observed. The conclusion, carefully worded and laden with implicit meaning, read, "Anomalous columnation consistent with localized venting or structured pathways." No one in the cautious language of science dared to claim explicit design, but no one staring at the symmetrical patterns could ignore the profound sense of order either. Somewhere between mere coincidence and deliberate intention, the truth waited a silent sentinel in the delta. If the jets were purely natural, they revealed a new kind of physics, a way for volatile materials to self-organize and regulate heat release with astonishing precision. If they weren't, then we were witnessing something far rarer, something almost mythological, an engineered system that had survived for billions of years now awakening near our sun. The change from silence to motion, from dormant rock to active structure was so abrupt, so precise. It felt like a switch had been thrown, a cosmic clock finally ticking after an eon of slumber. From that moment, 3I Atlas was no longer just a comet. It was an experiment, a cosmic riddle about how matter behaves when the familiar rules begin to bend, or perhaps were never quite understood. Scientists spoke softly when describing it, almost with reverence. It's as if the object remembered how to move. One wrote a sentiment that echoed in many field notes. But perhaps it did not remember. Perhaps it simply responded to heat, to light, to a condition woven into its very structure, long before the solar system even formed a pre-programmed echo of a forgotten origin. Whatever the reason, its sudden enigmatic change marked the beginning of a larger mystery, a profound reminder that even in the most predictable of systems, the universe still keeps a few surprises folded into its silence, waiting perhaps for the right angle of sunlight to reveal them like hidden characters on a fading scroll. For weeks after its perihelion passage, 3I Atlas drifted in silence. No visible jets, no optical flare, just the faint echo of sunlight glancing off what many now speculated was a surface far more complex than a mere cometary crust. Instruments around the world continued to listen patiently, meticulously, and heard nothing. The cosmos, it seemed, had returned to its usual indifferent hum. Then, on October 24th, the silence broke. From the high, stark desert of South Africa, the Meerkat radio telescope, a sprawling array designed to probe the deepest corners of the universe, caught something entirely unexpected, a narrow, clean signal at 1.665 GHz, immediately followed by another at 1.667 GHz. These were the twin peaks of hydroxyl absorption, the unmistakable molecular fingerprint of water vapour touched by sunlight. It was the first whisper, the first deliberate exhalation the object had ever made that was detectable across interstellar distances. Hydroxyl lines are ordinary in cometary science, a common sign that ice has begun to vaporise under solar heating. But what unsettled astronomers was not the signal itself, but its timing. The object had already passed perihelion, its closest approach to the Sun. By this point, the intense heat should have peaked and begun to fade, leading to a decline in activity. Yet instead of cooling into dormancy, 3I Atlas spoke. The question was immediate and precise, cutting through the scientific calm, why now? If the object's activity followed a purely thermal logic, its outgassing should have been strongest days earlier, when sunlight was at its most intense. But no signal was detected then. The first activation, the first whisper, came only after Atlas had begun to turn away from the Sun, as if some internal switch had waited for a specific alignment, then opened. At first, scientists assumed coincidence, a convenient if unsatisfying explanation. Perhaps a region of volatile ice deep inside the object finally fractured under residual stress, releasing a small burst of gas. But the spectral lines told another more intricate story. They were too narrow, too clean. A natural venting event, typically chaotic and turbulent, would scatter frequencies across a wide, noisy range. This, however, was steady, controlled, almost surgical in its precision. Professor Avi Loeb, ever the provocateur of conventional thought, called it methodical seepage, gas escaping as if through a valve rather than an explosion. It was a poetic phrase, but also an alarming one, for it resonated with a concept long relegated to science fiction. For decades, the idea of a comet regulating its own emissions had been an impossibility. But here was an observation that behaved precisely like regulation, not chaos. Balance, not eruption. Control, not random release. Could this be a purely physical phenomenon, a new undiscovered facet of material science? A group from the Max Planck Institute for Radio Astronomy proposed the insulated shell hypothesis. They envisioned the object coated in a dense carbon-nickel crust, acting as a thermal barrier, a cosmic cocoon. Heat from the Sun couldn't reach the interior immediately. It accumulated beneath the surface for days, building pressure, until it finally cracked a vent open. The result would be a single delayed pulse of outgassing, perfectly matching the timing of the radio detection. It was an elegant theory, a testament to the ingenuity of natural processes, but it raised one more crucial question. Why was the emission so stable, so calm? If a crust ruptured under extreme pressure, the event should be violent, a burst that fades within minutes, a quick explosive release. Instead, the hydroxyl lines persisted for 36 hours, unwavering, as though the vent stayed open just enough to release the built-up energy without losing structural integrity. It was the kind of exquisite balance a complex system achieves only when it implicitly knows how much to release, how much to hold back. Some called this the self-regulation scenario, the idea that the object's layered composition allowed it to naturally adjust outflow, maintaining equilibrium, like a biological process, a thermal heartbeat, carved in ice and stone beating across the void. Others leaned further towards speculation, their minds unmoored from the comfort of strictly natural explanations. If the pattern was too precise to be random, perhaps it was something else entirely, a triggered response. Maybe the Sun's radiation didn't just heat the surface. Maybe it acted as a signal, a specific wavelength, an exact intensity that resonated with something within the object. Imagine an object drifting for billions of years, inert, dormant until a certain combination of radiation, the right wavelength, the right intensity reaches its surface. Inside, something resonates, a chemical lattice, a conductive vein of nickel, an ancient cosmic circuit. The result is a pulse, a release, a reaction that looks like outgassing but feels unmistakably like awakening. Was that impossible? Perhaps. But the mathematics of coincidence, once a comforting bulwark against wild ideas, were growing thin, In early November, cross-observations from ALMA, the Atacama Large Millimeter, Sub-Millimeter Array, confirmed the same frequency, the same precise pattern, fading gently after 2 days. No other emissions followed one pulse, one breath, then silence. The data was sent to NASA and catalogued with a bureaucratic restraint that belied its mystery: transient hydroxyl absorption event, post-perihelion duration, 36 plus 3 hours, no recurrence observed. That was all the official record would say. But among the scientists who had seen the live feed, something lingered, a feeling that the silence after the signal meant more than the signal itself. If it was a natural event, it was extraordinarily disciplined. If it was something else, it was extraordinarily discrete. Either way, the moment marked a boundary, a point where physics and wonder blurred into the same enigmatic line on a graph. What turned 3i Atlas from silent rock to speaking comet? A fracture, a resonance, a memory no one could answer. No one could. The object continued outward, shrinking into the distance, the echo of its brief whisper fading beneath the cosmic background noise. And yet on the record, those twin lines remained thin, perfect, immutable. They remind us of a simple truth that humbles every scientist. Even silence, when it ends, carries meaning that transcends mere absence. By early November, the calculations no longer matched the sky. The predicted orbit of 3i Atlas, meticulously drawn from weeks of optical tracking, began to slip. At first, the offset was minuscule, a fraction of an arcsecond barely measurable, then far enough to shatter certainty. The object was subtly yet undeniably moving away from gravity itself. Every known comet obeys the colossal mass of the Sun, its path a predictable ballet orchestrated by gravitational pull. Its spin can change, its volatile composition can shift, but all motion invariably follows the pull of mass and light, a fundamental law of the cosmos. Yet Atlas drifted with a smooth, steady bias, as though an invisible hand were adjusting its course, guiding it with deliberate precision. No measurable collisions, no powerful solar storms, no visible outgassing could explain this phantom force. When the ALMA and Pan-STARRS data sets were combined and analysed, the deviation grew undeniable, mathematically precise. The force required was minute, approximately 2 stan nin vol 7 mes2, but consistent, sustained over millions of kilometres. That whisper of thrust was enough to subtly reshape its trajectory over time. The term laden with unspoken implications entered every official report: non-gravitational acceleration. In theory, such a drift can arise when sunlight heats one side of a comet more than the other, causing gas jets to push it unevenly, a phenomenon known as the Yarkovsky effect. But Atlas had already defied that rule with its perplexing jets. Its observed emissions were faint symmetrical, and by this point fading. If the thrust came from sublimation, the direction should oscillate, with its rotation a wobbling, unpredictable push. Instead, the acceleration vector stayed constant, aligned almost perfectly with its orbital plane, as if the object knew precisely where it wanted to go, a predetermined destination. Scientists, ever bound by empirical rigour, resisted that thought. They frantically searched for hidden variables, for any conventional explanation: thermal lag, mass misestimation errors in star catalogues. But each correction, each painstaking recalculation only tightened the curve of the anomaly. It remained. A non-gravitational cause, particularly one so precise and sustained, meant one of two profoundly unsettling things. Either the object was producing force from within some natural but utterly unknown venting system, or its motion was being influenced by something beyond ordinary mechanics, a force external or internal, that defied our current understanding of celestial bodies. The first possibility led to models of subsurface propulsion, a complex network of sealed chambers beneath the crust where trapped volatiles built pressure, escaping through microscopic vents invisible to our most powerful telescopes. Each individual release would be too gentle to form a visible coma, too subtle to detect directly. Yet together, they could generate a steady, continuous push. The physics, to its credit, worked barely. The precision, however, bordered on artistry. if random cracks were responsible, the thrust should fluctuate in erratic dance. It didn't. For 9 continuous days, its velocity increased in a perfectly linear line. No spikes, no tremor, no noise. It was motion with intent, or at least with a baffling, almost conscious discipline. That word discipline unsettled the community, for discipline implies control, and control in turn implies design. Some whispered the comparison everyone had avoided the ghost of another interstellar visitor, Oumuamua. In 2017, the first interstellar visitor had shown the same gentle, inexplicable acceleration unexplainable by outgassing. At the time, scientists called it coincidence, a rare isolated event. Now, coincidence was repeating itself not as an echo, but as a pattern, a disturbing resonance across the void. Could both objects share a hidden architecture, a structure that reacts to sunlight not merely as heat, but as a stimulus, a command? Could thin metallic layers beneath their surfaces absorb radiation and release it as directed motion, a kind of photon-regulated drive? If so, it might represent a natural phenomenon never seen before, a physics yet to be discovered, or a technology so ancient, so weathered by eons, that it had merged seamlessly with nature itself. The idea split the field, bifurcating into 2 uncomfortable camps. Half demanded new physics, a complete re-evaluation of our cosmic models. Half demanded humility, a recognition of our vast ignorance. But all agreed on one undeniable fact. The sun's gravity, the very fabric of celestial order, was not enough to describe what they saw. In Cambridge, A.V. Loeb offered a calm, almost poetic summary, cutting through the fervour. The acceleration is small, constant and unexplained. Whether it is natural or artificial, it teaches us the same lesson, that we still do not understand how some matter moves between stars. Outside the cold clarity of the equations, a subtler, more profound meaning began to take shape. Maybe this wasn't propulsion in the human sense, not an engine, or a deliberate course correction. Maybe it was something far more ancient, more profound, a response of material memory, a deep-seated reaction to light after billions of years of exposure, a fossil of motion preserved across unimaginable stretches of time. Imagine an object forged in another star system, its very minerals aligned in a magnetic field, long vanished its atomic structure imprinted by cosmic forces beyond our ken. Now under our sun, those same atoms awaken subtly repelling or absorbing radiation, unevenly creating a drift that mimics intention. The cosmos itself, in this view, becomes the engine, the grand indifferent designer. To an observer, the result is indistinguishable from choice. A rock moves where it shouldn't, and we in our anthropocentric bias assign it will. But perhaps it is simply obeying laws we have yet to write echoes of a physics from a universe older than ours. By mid-November, the deviation stabilized, freezing Atlas into a slightly altered path that would carry it past Mars and back toward the outer dark, a new trajectory etched by an unseen force. The acceleration ceased as suddenly as it began, like a breath released after a sustained effort. No one could say whether the effect was truly over or merely paused. If the mechanism was internal, a self-regulating system, it might reignite when sunlight struck a new angle. Months later, a sleeping giant stirring once more. If it was something else, something guided, then perhaps the mysterious course correction was complete, its objective achieved. The final data release read, with bureaucratic restraint masking the underlying wonder, observed deviation consistent with sustained non-gravitational acceleration mechanism undetermined. Yet behind that sparse sentence lay a profound sense of awe. A silent traveller, a fragment of an ancient forgotten order, had shrugged off gravity's chain and rewritten its own orbit, not with fire and fury, but with a quiet, persistent whisper of thrust. It reminded every scientist watching that even the most elegant equations, the most fundamental laws are still only guesses, temporary agreements with a universe that refuses to be fully contained. In a cosmos measured by attraction and pull, 3 Atlas moved as if remembering freedom, gliding through sunlight with the quiet confidence of something that simply refuses to fall. When 3Ti Atlas finally reached the far side of the Sun, its perihelion passage complete telescopes expected to see it fade, its heat dispersing its brightness, falling into ordinary silence. Instead, what appeared was something no cometary model could easily contain, a labyrinth of jets moving not as chaos but as geometry. From the Very Large Telescope in Chile, high-resolution imaging revealed at least 5 active outflows, each pointing in a different distinct direction. One streamed along the orbital path a conventional trail, another angled sharply north a puzzling deviation, and then against all expectation one singular jet pointed directly toward the Sun, a brazen defiance of all known physics. That single jet, a thread of luminous vapour pushing against the very source of light, rewrote the rules. Cometary physics dictates unequivocally that solar radiation pressure pushes all material away from the Sun. It is the fundamental reason every comet grows a luminous tail pointing outward, a celestial arrow. Yet here was Atlas releasing matter in the opposite direction, matter that seemed to resist that radiation rather than flee from it. The data was clean, incontrovertible. Spectral maps confirmed a persistent sunward jet steady over several days, its brightness oscillating with the object's slow rotation. It wasn't an illusion, nor an observational artifact, nor an error in calibration. Something deep within the comet's structure was actively pushing back against the Sun. Scientists frantically searched for a natural explanation, wrestling with the implications. One idea suggested a daylight-nightlight asymmetry. Perhaps the jet came from the shaded side, where trapped gas escaped through deep fissures and erupted along a path that happened to aim toward the Sun. But that still failed to explain the stability, the sheer persistence. The jet held its alignment for nearly a week, far too long for random venting from a fracturing surface. Another theory proposed electrostatic repulsion. As the solar wind charged the comet's surface, particles might have been ejected along magnetic field lines that curved back toward the star. A neat concept, elegantly leveraging known forces, yet the required charge density was astronomically high, far beyond anything measured or considered plausible for a natural body of this kind. That left the uncomfortable, almost heretical possibility that the direction was intentional, or at least meticulously regulated. If internal channels directed the gas flow through hardened conduits beneath the crust, the result could be a columnated stream capable of overcoming weak solar pressure. Such systems exist naturally on smaller scales in cryovolcanism, where heat and pressure focus into narrow vents producing symmetrical plumes. But Atlas's pattern was too perfect, too rhythmic, too enduring, almost engineered by its own mineral logic, a silent architect within the ice and stone. At the same time, another mystery emerged, shifting the focus from dynamics to chemistry. Observers noticed a dramatic colour shift. Before perihelion Atlas glowed with a dull reddish hue, typical of dust-rich comets, a familiar comforting shade of the ancient solar system. Afterward its tone changed abruptly, strikingly, to a deep metallic blue, a transition recorded across multiple instruments confirming its reality. The shift was not gradual. It happened within days, a sudden, inexplicable metamorphosis. In astronomy, colour reveals chemistry, a cosmic fingerprint of composition. Red typically means dust and complex organic carbon molecules. Blue means reflected light from smaller particles or emission from excited gas. But the sudden dominance of blue defied both established trends. One possibility was Rayleigh's scattering light scattering through ultrafine particles, smaller than a micron, producing the blue wavelengths. That would imply the object was shedding dust grains far smaller than expected, perhaps the residue of a vaporized crust. Another was molecular emission. Cyanogen CN and diatomic carbon C2 can glow blue-green when sunlight excites them. Yet their spectral fingerprints were weak, almost absent, rendering this explanation incomplete. So what caused the shift? A joint team from NASA's Infrared Telescope facility and ESA's Rosetta Archive group compared the reflectance data with known cometary spectra. They found something extraordinary, something that silenced conversations in many labs. The pattern matched not carbon dust, but nickel-rich silicates minerals that reflect blue light under intense solar heating. Nickel. Again. It was the same element already noted in earlier analyses of the object's unusual density and peculiar spectral absorption lines. If true, the blue glow might not be gas at all, but metallic reflection, the exposed skin of a nickel-bearing surface reacting to solar radiation. That idea changed everything. It meant that beneath its dusty outer shell, 3I Atlas could harbour a core made of heavy elements rarely seen in comets, materials more typical of planetary interiors, or more disturbingly manufactured alloys. The speculation spread quickly, then quietly like a current beneath the surface. Was it possible that this interstellar traveller wasn't a mere chunk of primitive ice, but a fragment of something far older, something forged in the heart of a destroyed world, or perhaps built for purposes long forgotten? The idea was uncomfortable even to those who entertained it. No one wanted to say, artificial to cross that line, but everyone felt it hovering behind the data, a presence as persistent as the sunward jet itself. For now, the working consensus was restrained, a shield against the unsettling implications, observed colour change consistent with thermal alteration or exposure of reflective subsurface material. A neutral line in a paper that concealed deep unease. When the light curve models were overlaid, a rhythm appeared, unmistakable brightness rising and falling, with rotation synchronized with the shifting hues. Every turn of Atlas revealed another facet, another glint of metallic blue. To the eye it was beautiful, an ethereal dance of light and shadow. To physics it was profoundly unsettling. How could something so small and ancient carry such order, such intricate synchronicity? How could a body primarily composed of dust and ice shine like polished metal under the sun? Maybe, as one astronomer wrote in his notes, it's not resisting the sun, it's remembering it. Perhaps that was true. Perhaps the strange sunward jet and the sudden blue light were not defiance but memory, the echo of an origin in a place where the laws of heat and pressure once shaped it, differently imprinted a form of resilience. Or perhaps we were simply witnessing how the universe expresses precision without purpose, how astonishingly complex natural processes can mimic the products of intent. In either case, the sight of that cold blue traveller reminded us that even the simplest laws of light can still surprise us, that colour, like gravity, sometimes bends toward mystery, drawing us deeper into the unknown. In science, silence is supposed to mean certainty. Data under rigorous review analysis and progress conclusions forming carefully meticulously. But in the unsettling case of 3I Atlas, the silence began to sound like avoidance, like a deliberate withholding. Weeks after the object's profound encounter with the sun, researchers around the world expected a full, transparent data release. Instead, what arrived were fragments, truncated summaries, partial tables, and most crucially missing images. The official explanations were ordinary, almost mundane calibration delays, cross-checking protocols, data compression issues. And yet behind closed conferences in hushed corridors, whispers began to circulate, gaining momentum. What exactly are they not showing us? The first to speak publicly to break the institutional quiet was Dr. Michio Kaku. In a widely publicised interview, he accused NASA of unnecessary secrecy, his words cutting through the usual scientific decorum. If this object is just a comet, why hide the images if it isn't? Why pretend everything is normal? It was a sharp question wrapped in a veneer of calm, and it struck a nerve resonating with a public already intrigued and unsettled. For decades, the world's leading space agencies have shared comet data freely, a cornerstone of open science. From Comet Hale-Bopp to 67P Churyumov-Gerasimenko, every image, every spectrum, every anomaly had been made public within days, fostering a sense of shared discovery. But with Atlas high-resolution images from the Mars Reconnaissance Orbiter MRO, captured on October 2nd and 3rd, were inexplicably delayed for more than 3 weeks. When they finally appeared, they were cropped, compressed, and quietly filed without announcement, a soft burial of potentially crucial information. What they showed, or perhaps more importantly what they didn't show, became the centre of a heated, unresolved debate. Insiders described the raw images as visually unusual, terms that hinted at forms and features inconsistent with expectations. Unconfirmed leaks mentioned sharp surface contrasts, almost architectural shadows inconsistent with the smooth, often chaotic contours of known comets. Others, proponents of the conventional narrative, dismissed these observations as overexposure, a trick of light artifacts of digital correction. But the timing was undeniably strange. In the same week the data was withheld, Congresswoman Anna Paulina Luna sent a formal request to NASA demanding the release of all Mars-based imagery related to Atlas. Her statement cited possible irregularities in the data pipeline and unexplained delays inconsistent with standard planetary imaging schedules. A few days later, a second equally pointed request followed, this time asking for telemetry from Perseverance, the rover on Mars, which had reported unusual activity in the upper atmosphere on October 5th. Officially, the rover was never looking at Atlas. Unofficially, it was in precisely the right position to detect its light. What was this unusual activity? The public reports remain conspicuously blank, an empty space where clarity should have been. To be clear, most scientists don't believe in conspiracies. The daily grind of data takes time, instruments fail, funding cuts loom. But the pattern of delays, the missing frames, the unusual caution for something labelled a standard interstellar comet was undeniable, a subtle but persistent distortion in the scientific signal. In internal memos later leaked to journalists, one line stood out, a masterpiece of bureaucratic euphemism. Certain imagery may require contextual analysis prior to release. Contextual analysis, a phrase that said everything and nothing, designed to obfuscate rather than clarify. What kind of context does an image of a rock need beyond its scientific parameters? Some speculated that the delay stemmed from data saturation, that the raw files contained optical flares or pixel noise that to the untrained eye looked like artificial geometry provoking unnecessary alarm. Others whispered of signal contamination, perhaps the radio instruments picked up reflections or interference from the object itself, an unintended echo of its presence. Whatever the true reason, the effect was the same. The public narrative slowed, the mystery deepened, and Through-Eye Atlas drifted deeper into a shroud of secrecy. Even now, fragments of those missing images surface, occasionally blurry reproductions adjusted for contrast, shared by anonymous technicians passed around in online forums. In one, the object appears almost faceted, as if its surface were divided by panels of different reflectivity. In another, the sunward jet glows with a uniform blue hue, not the irregular pattern of dust or gas. Each pixel, each hint becomes an argument fueling the debate. NASA has neither confirmed nor denied their authenticity. Instead, their statements remain procedural, meticulously guarded. Images are being processed for scientific accuracy and will be released once validated. Weeks turned to months. The validation, the promised clarity, never came. Transparency, once a cornerstone of space science, began to feel conditional, a privilege rather than an inherent right of discovery. Some defended the caution, arguing that data must be absolutely correct before it's public to prevent misinformation. Others countered that the delay itself distorts truth, creating suspicion where none may exist, eroding public trust in the very institutions tasked with revealing the universe. Between those two positions lies the uncomfortable core of modern science, the perpetual uneasy balance between certainty and openness. Perhaps what's being hidden isn't a revelation but confusion. Perhaps even the experts behind their guarded statements don't yet understand what they're seeing, are struggling with a paradigm shift. In one closed symposium, a senior astronomer reportedly uttered a sentence that never appeared in the official transcript. "If the images show what I think they do, we will need a new vocabulary." Outside the cloistered world of official science, the story evolved on its own. Untamed documentaries, interviews, fervent conspiracy threads. Some claimed Atlas was an ancient probe, a silent sentinel from another star. Others insisted it was a natural object, simply misread by overzealous minds. In truth, the only mystery greater than the object itself was how little anyone seemed willing to definitively say about it. And so, between the fever of speculation and the chill of official silence, VI Atlas became something rare, something profound, not just a question of physics, but a fundamental question of trust. When data disappears, meaning multiplies, filling the void. When silence replaces explanations, imagination, often untethered, fills the vacuum. And somewhere in that widening gap between what we know and what we're allowed to see wonder begins to sound like a warning. Maybe nothing was hidden at all. Maybe the real unsettling secret is simply that we still don't know what to believe. By the time the fervent debate over missing data began to fade, subsumed by new crises and distractions, another revelation was quietly emerging, one buried not in secrecy, but in the cold, hard numbers themselves. Spectral analysis of 3I Atlas suggested something extraordinary, something that echoed through unimaginable stretches of cosmic time. This traveller from the void was older than the solar system itself. The isotopic ratios of oxygen and carbon within its structure were incompatible with any known bodies born under our sun, a clear chemical signature of a foreign origin. Their precise fingerprints meticulously measured by infrared spectrometry and cross-verified by the advanced capabilities of ALMA, pointed unequivocally to formation in a star system at least 7 billion years old. Older than Earth, older than the Sun, older even than the planets that now observed it. That single staggering number changed everything. If true, it meant Atlas was not merely a visitor, a casual wanderer, but a true relic, a survivor of a long-dead star carrying within its very atoms a record of conditions that profoundly predate our cosmic neighbourhood. Its structure, its peculiar orbit, even its stubborn resilience in the face of solar forces all might trace back to that forgotten place, a universe of billions of years ago. But where could it have possibly come from? Models of galactic motion suggest that over billions of years, stellar systems drift, collide and dissolve into one another like waves crossing an infinite ocean. A fragment ejected from one such system could indeed wander into stellar space, indefinitely frozen, bombarded by cosmic rays, altered molecule by molecule by the relentless march of time itself. Yet 3I Atlas did not look eroded or ancient in the way one would expect. It looked preserved, almost pristine, as though it had been shielded, protected, or perhaps meticulously maintained through the eons. When the surface composition was reconstructed from the spectra, another profound surprise emerged, a nickel-to-iron ratio several times higher than that of typical comets. Nickel, a metal renowned for its resistance to corrosion, an element that forms crucial alloys used in spacecraft, in turbines, in the very infrastructure of advanced technology, not the brittle ices and silicates that define natural comets, those primitive building blocks of stellar nurseries. Some scientists immediately suggested a plausible, purely natural origin. Perhaps Atlas was a fragment of a planet's metallic core torn apart when its parent world collided with another during the violent, chaotic youth of its star system. If so, its composition would certainly explain its astonishing resilience. A shard of a world's heart refined by unimaginable pressure and the crucible of time. But even that compelling scenario failed to account for the precise balance of elements, the intricate interplay observed. The object's reflectivity, its magnetic response, its astonishing heat retention, all suggested an engineered alloy, a mixture not typically found in the messy, often random processes of planetary formation models. Of course, no one dared publish that conclusion outright. In the careful, circumspect language of scientific papers, they called it non-standard metallic enrichment. In private, among trusted colleagues, some quietly, almost fearfully, called it impossible, If this object had indeed travelled for 7 billion years enduring untold collisions, the searing radiation of countless cosmic rays and temperatures near absolute zero, then what preserved its internal symmetry? Why did its surface reflect light like polished mineral, like a finely crafted artifact, not like fractured, chaotic stone? A few pushing the boundaries of conventional thought proposed that Atlas could be the remnant of a technological civilization, not an intact machine, but debris, a piece of something larger, once functional, now eroded into myth and legend. A drift of interstellar wreckage mistaken by our instruments for ice and dust. That idea, while electrifying to the imagination, faced the same fundamental problem as all bold hypotheses proof. The data in its frustrating ambiguity offered none. Only suggestion patterns and a growing pervasive unease. Still, the string of coincidences was haunting, refusing to be dismissed. The unusual composition matched no known class of natural objects. The metallic core model explained much, but not everything, leaving tantalizing gaps. Its reflective spectrum mirrored nickel-iron composites, strikingly similar to those used in engineered materials on Earth. Its thermal stability exceeded the limits of porous rock, hinting at a robustness that defied natural explanation. And its magnetic response behaved not like a random mass, but like an organised field, a subtle, structured influence. Could these simply be natural consequences of an alien environment, a universe whose rules we have yet to fully comprehend? Or were they the enduring remnants of a design so ancient, so weathered that it now behaved indistinguishably from geology itself? To definitively answer that, we would need to know the system it came from to trace its lineage. But the galaxy in its vast, indifferent passage of time had long erased that trail. All we could trace was a faint corridor in space, its trajectory reaching back toward a region only 9 degrees from where the legendary WOW signal was recorded in 1977. Coincidence, most said, a statistical fluke. And yet the human mind resists coincidence when patterns begin to repeat, when elegant symmetries emerge from the noise. If Atlas indeed came from that corridor, it would mean it had been drifting across the Milky Way for eons, perhaps guided by blind chance, perhaps by an ancient deliberate purpose. What kind of civilization could fashion and send a fragment across such unimaginable distances through such hostile emptiness? Or what kind of cosmic accident could forge an object so precise, so enduring, that it looks to our limited eyes like intention? Even if purely natural, its existence was still a kind of message, a profound, unsettling proof that materials can survive longer than worlds, that memory can exist without mind. Imagine a piece of a dead star system still glimmering under another sun, whispering through the void in frequencies we barely understand, a silent testament to endurance. It doesn't need to be a ship to carry meaning. Its meaning is survival itself. One astronomer grappling with the profound implications wrote in his notes, "Maybe 3i Atlas isn't a messenger, maybe it's a fossil, the memory of an attempt that outlasted its makers." There is something profoundly humbling in that thought, a quiet awe. In a universe that ultimately forgets everything, planets, species, even stars here, drifts a small, silent remnant that remembers, that carries an echo of a beginning. Its metals forged in another dawn, its surface burned by alien suns, its story written in isotopes rather than language. Perhaps that is the true, deepest secret of Atlas. Not that it hides technology, but that it is technology, the kind that nature and time in their grand indifferent dance create together, blurring the lines of our convenient definitions. As it continues outward, now past Mars, into the cold, silent depths where sunlight fades and silence deepens again, it carries no easy answers, no definitive pronouncements. Only the quiet, stubborn endurance of matter older than Earth, older than memory, proof that in the vast, elegant machinery of the cosmos, survival itself can be an act of profound, almost artistic design. It began as a faint coincidence, the kind that scientists with their rigorous training are taught to ignore, to filter out as noise. But in the grand, unfolding narrative of cosmic investigation, sometimes a coincidence is all we have. When the first precise orbital projections of 3I Atlas were compared against deep space radio archives, a subtle, almost ethereal pattern appeared. Its inbound trajectory, the narrow corridor of interstellar space it had crossed before gracefully entering our solar system, pointed to a region strikingly close to the coordinates of the legendary WOW signal. That mysterious narrowband radio burst a singular spike of cosmic static. Recorded in 1977 by the Big Ear Observatory in Ohio, had lasted just 72 seconds, never to repeat. It was a frequency of neutral hydrogen, 1420 MHz, the most universal abundant element in the cosmos, and for that profound reason long considered the logical fundamental channel for any civilization wishing to announce its presence across the vastness. Now, nearly half a century later, another anomaly had appeared in its vicinity. One also centred near hydrogen frequencies, also transient, also stubbornly unexplained. Atlas's post-perihelion radio emissions, those perplexing whispers, detected at 1.665 and 1.667 GIS, fell within the same fundamental electromagnetic family: hydrogen and hydroxyl, the two ends of the cosmic water molecule H2O, the very solvent of life itself. It could be coincidence, of course, a statistical happenstance in an infinite universe. But coincidences this elegant, this resonant, tend to make scientists profoundly uneasy. Dr. Avi Loeb, ever meticulous, ran the numbers. He calculated the probability that two independent phenomena separated by nearly 50 years would align both spatially and spectrally by pure chance. The odds, he concluded, were vanishingly small, approximately 1 in 10,000. Not impossible perhaps, but certainly enough to warrant a significant pause to demand a deeper look beyond the convenient label of random. What made the link even more intriguing was the striking behavioural symmetry. Both events were sudden abrupt appearances in the cosmic quiet. Both were short-lived transient flashes that defied recurrence. Both occurred at frequencies intrinsically tied to the chemistry of life, the foundational elements of existence. And both came from directions with no known pulsars, no quasars, no repeating astrophysical sources that could account for their origin. For the first time, serious researchers typically grounded in conservative empiricism began to whisper the question they'd avoided for decades. A question that verged on the audacious, what if the WOW signal wasn't random noise or a terrestrial interference, but a true point of origin, a beacon? Could 3I Atlas be a fragment from the same cosmic region, or in the more daring versions of the hypothesis, a piece from the very source that sent that long-lost solitary transmission? Skeptics moved quickly, as is their duty, to ground the discussion in established science. Hydrogen frequencies, they argued, are common throughout the galaxy, a ubiquitous hum. Any alignment, they posited, could be coincidence. Any signal a product of subtle reflection, any mystery an illusion of human pattern, seeking our innate tendency to find order in chaos. And yet even the most rigorous skeptics could not entirely ignore the uncanny alignment. When the Harvard-Smithsonian Center for Astrophysics reprocessed the old 1977 data, with modern algorithms, faint sidebands appeared subtle fluctuations around the main hydrogen line, matching the offset frequencies of hydroxyl. It was not definitive proof, not a smoking gun, but it was enough undeniably to reopen the conversation, to stir the dormant questions. Could these two phenomena, separated by time, but profoundly connected by spectrum, represent two halves of a single cosmic message: hydrogen plus hydroxyl, the elemental formula for water, the universal solvent of life? If intentional, it was elegant beyond words, a profound minimalist statement. If natural, it was coincidence raised to the level of poetry, a profound, exquisite accident. The thought that perhaps we were not looking at a mere comet, but at a messenger, or at least a relic from the same cosmic neighbourhood that once whispered, "Wow!" across the void, unsettled even the most disciplined minds, forcing a profound re-evaluation of our place in the cosmic tapestry. In closed meetings, researchers debated whether to even mention the correlation publicly, fearing the accusations of sensationalism and pseudo-scientific overreach. To connect Atlas with the WOW signal was to step firmly into the realm of speculation, to blur the line between science and science fiction. But the numbers were persuasive, the patterns undeniable, and curiosity that most human of drives has always been stronger than caution. Some proposed an intermediate theory, a resonant coincidence. Maybe both phenomena stem from natural hydrogen resonance in dense interstellar clouds, a kind of cosmic echo chamber that amplifies specific frequencies, creating transient signals that appear deliberate. Atlas passing through such a region eons ago could have inherited isotopic patterns from it, explaining both its radio signature and its unusual chemistry. In that sense, it was not the sender of a message, but a souvenir of the very place where the message originated, a physical fragment carrying the imprint of a cosmic event. Others leaned further into metaphor, into a philosophical interpretation. If the wow signal was a hello, a distant wave, perhaps Atlas was the footprint, the physical trace of a civilization that once called out, now reduced to silence and motion, its message carried by a fragment of its world. No one could prove it, of course, but the profound symmetry between hydrogen's voice and Atlas's glow haunted everyone who studied it, demanding an explanation that transcended mere chance. In an essay published quietly in Astrophysical Letters, Loeb concluded his words echoing across the scientific landscape. Whether the similarity is physical or symbolic, it demands humility. Two events separated by half a century may together represent a single phenomenon we do not yet have the language to describe. And perhaps that is the ultimate lesson, hidden beneath the data, shimmering just beyond our grasp. The universe rarely repeats itself, but when it does, when an echo sounds across billions of years and light years, it may be whispering a pattern we have yet to recognize, a profound, recurring motif in the grand cosmic symphony. The trajectory of Atlas and the direction of the wow signal cross only briefly in the vast, intricate map of the galaxy, a fleeting overlap in the great dance of matter and meaning. But to those who have traced both paths, who have seen the patterns emerge, it feels less like coincidence and more like conversation, a dialogue spanning impossible scales. Maybe the signal and the object share nothing at all but timing and chemistry, a beautiful but meaningless alignment. Or maybe across billions of years and countless light years, they are two syllables of the same cosmic sentence, one written in radio waves, the other in light, a message broken into fragments across deep time. And as always, the universe leaves us to wonder in our quiet watchfulness, whether it was speaking directly to us or simply reminding us gently, profoundly to listen. When the last data sets were compiled and the final confirmed orbit of 3i Atlas was charted, the object was already fading from sight, a quiet ember retreating into the cold, silent expanse beyond Mars. Its story, however, refused to fade. Across observatories and institutions, from the hallowed halls of Cambridge to the bustling labs of Tokyo, one conclusion began to crystallize with unnerving clarity. Whatever 3i Atlas was, it did not fit the model. Not for a comet, not for an asteroid, not for any known fragment of cosmic debris. It was purely and simply an anomaly, a stark, unwavering reminder that the universe still holds more exceptions than rules, more mysteries than solved equations. In the sterile clarity of our equations, we like to think we understand how matter behaves, how light scatters, how dust sublimates, how orbits bend with predictable grace. But then something arrives from the dark, from the unimaginably distant, and behaves otherwise. It follows no familiar pattern, obeys no comforting expectation. It teaches us through its sheer defiance that our laws are only temporary agreements with nature, provisional truths valid only until the next stranger passes by, rewriting the script of reality itself. Atlas has given science more profound questions than comfortable answers, a structure that breathes without a tail, an acceleration without discernible thrust, a signal without repetition, a colour without familiar chemistry, and a silence that feels deliberate, heavy with unstated meaning. Each of these puzzles may yet find an explanation in physics and probability, or in our own deeply human tendency to see meaning where there is only complexity. But until we admit what we truly do not know, until we embrace the limits of our current understanding, true discovery remains impossible, locked behind the walls of our certainty. The object's passage forced astronomers to confront an uncomfortable duality that often lies at the heart of genuine scientific progress, that skepticism and imagination are not opposites, but indispensable partners. To observe a profound mystery without immediately declaring it miraculous, to speculate with open minds without surrendering to unreasoning belief, that truly is the arduous discipline of science. We can calculate trajectories with perfect precision, but curiosity, that eternal human spark, still demands humility. Every time we claim certainty, the cosmos in its infinite complexity offers correction, a gentle nudge back to the unknown. When asked about the ultimate meaning of Three-Eye Atlas, Avi Loeb summarized it with disarming simplicity, cutting through the layers of scientific jargon. Either it is a new kind of natural body one never before imagined, or we have witnessed the remains of something once made. In both cases, our understanding of the universe must radically expand. That statement captured the spirit of this precise moment, a rare, thrilling intersection of hard data and boundless wonder. For if Atlas is indeed natural, then nature has in some profound, unprecedented way learned to imitate purpose to craft systems that appear designed. If it is not natural, if it is a relic of intention, then purpose has endured silently across eons long enough to become indistinguishable from nature itself. Either way, the distinction once so rigid begins to blur, dissolving into a new, unsettling understanding of cosmic reality. Throughout history, every truly revolutionary leap in science began not with confidence, but with confusion, with a stubborn anomaly. The heliocentric model began as heresy, a radical defiance of established truth. Quantum mechanics began as a series of contradictions defying common sense. Even the elegant theory of relativity was born from a failure to explain a small, stubborn anomaly in the speed of light. Perhaps Atlas is another such anomaly, a quiet herald of physics, yet to be written a harbinger of a new cosmology. The lesson it leaves us is not to blindly believe in aliens or miracles, but to believe deeply existentially in the unknown. To treat each anomaly not as a threat to our understanding, but as an invitation, a doorway to deeper truth. To let the data speak unburdened by preconceptions before dogma translates it into comfortable, familiar terms. Because what if the next visitor arrives, or the next pattern emerges from the noise, and we are too certain, too complacent in our knowledge to notice what it truly means? Transparency, open data, and rigorous cross-disciplinary dialogue are not luxuries in this endeavour. They are absolute necessities for navigating a universe that persistently refuses to fit our neat models. When information is withheld, even for the most cautious reasons, speculation like a pervasive fog fills the void. When science closes its doors, when dialogue is stifled, mystery inevitably becomes myth, and myths once born into the human psyche are extraordinarily hard to silence. That is why the true enduring legacy of Three-Eye Atlas may not lie in what it ultimately was natural or artificial, but in what it taught us about ourselves, our profound need for control, our inherent fear of error, and our fragile eternal balance between wonder and proof. If the cosmos could speak directly, perhaps it would tell us in a voice as old as time, "Do not rush to define me. Watch longer, listen better, doubt more gently." Maybe the object was nothing more than a comet made strange by an improbable coincidence of angle and chemistry. Or maybe it was something greater, something far more profound, a fragment of memory, a shard of intention, a message written not in words but in sheer astonishing endurance. Whatever it was, it came, it glowed, it whispered, it accelerated, and it left quietly, rewriting our sense of what might truly drift between the stars. And in its wake it leaves a single timeless commandment for every scientist, every dreamer, every listener who looks into the dark searching for answers. Stay curious, stay honest, and never mistake silence for absence.